In the shadow of Geneva, underneath the Earth's surface, lies a wonder of human inventiveness and a likely harbinger of destruction, the Huge Hadron Collider. It is a reference point of logical investigation, permitting researchers to look into the subatomic world, and has prompted the revelation of the perplexing God particle a long time back. However, now, renowned physicist Brian Cox has recently made a chilling declaration that has sent shock waves throughout the scientific community. Something disturbing has been identified at CERN, something that could have consequences far beyond our understanding. Has our journey for knowledge set us on a crash course with disaster? Join us as we dig into the chasm of this scientific conundrum. However, before we delve into the declaration, understanding what is significant about the God particle is essential. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets and the world's largest and most powerful atom smasher. It represents the zenith of human scientific achievement. In fact, it's so powerful that it can reproduce the very states of the universe's birth. But could this machine, intended to unlock the mysteries of the universe, hold the key to something undeniably more inauspicious? CERN, established in 1954, is one of the world's most prestigious research organizations, with 23 member states and thousands of researchers. It is a center for collaboration and innovation. The LHC is CERN's flagship project, but it's only one part of an immense network of accelerators and experiments. Imagine a racetrack, not for cars or horses, but for subatomic particles, and it's a race against existence itself. The LHC speeds up protons to almost the speed of light, sending them on a collision course that imitates the energy of the universe at the time of the Big Bang. The crashes create temperatures 1,000,000 times hotter than the core of the Sun. Large numbers of magnets guide the protons on their journey, while intricate cooling systems keep the magnets at temperatures colder than space. These include 1,232 dipole magnets that bend the beams and 392 quadrupole magnets that focus the beams just before collision. Another type of magnet is used to squeeze the particles closer together to increase the chances of collisions. The task of causing them to impact is akin to firing two needles 6 miles apart with such precision that they meet in the middle. The accuracy required is astounding, the technology unmatched. The LHC's design is a marvel of engineering. It comprises two neighboring parallel beamlines that lie buried 574 feet beneath the surface, shielded from the Earth's radiation. In this underground world, the entire system is cooled to a temperature of -456 degrees Fahrenheit, colder than the vacuum of space itself. This freezing environment is essential for the superconducting magnets to function optimally. The beams inside the LHC are made to collide at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors: ATLAS, CMS, ALICE, and LHCb. Each serves a unique purpose, investigating different aspects of particle physics. Together, they act as enormous cameras, capturing images of these impacts. Researchers then sift through the debris, searching for signs of the elusive Higgs boson, otherwise known as the God particle, and other phenomena that clue us into the universe's fundamental building blocks. It's like sorting out a massive jigsaw puzzle, one where the pieces are invisible and the picture is obscured. By concentrating on the microcosm, we gain insights into the macrocosm. However, with each answer comes another question, and with each discovery, another challenge. The LHC isn't merely a scientific instrument, it's a demonstration of human curiosity and innovation. It encapsulates our relentless quest for knowledge and our desire to understand the key forces that shape our universe. Yet, as we push the limits of what we know, we must also consider the moral and existential questions that arise. What are the dangers of probing the unknown? Could our quest for understanding inadvertently unleash forces we cannot control? In the hallowed halls of CERN, where the limits of human understanding are continually pushed, a revelation has emerged that sends a shudder down the spine of even the most prepared scientists. Brian Cox, a former researcher at CERN and a prominent voice in the realm of particle physics, has recently made a statement that has left the world both captivated and apprehensive. Cox's words resonate with eerie clarity. The objective of CERN's Large Hadron Collider is to reproduce a scaled-down Big Bang. Yes, you heard that right, a miniature version of the very event that gave birth to our universe. The physicist also explained the implications of this goal, highlighting the LHC's unprecedented potential for making new discoveries. This includes its capacity to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to summon the very fabric of the universe. It's an enticing prospect, but one fraught with peril. The miniature Big Bang isn't merely a theoretical concept, it's a tangible reality within the LHC. The temperatures, the pressures, the raw energy, all replicate the conditions of the universe's infancy. It's like standing at the very beginning, witnessing the birth of existence itself. However, with such power comes responsibility, and a haunting question looms: what if something goes wrong? Something did go wrong, in fact. Back in 1978, Russian physicist Anatoly Bugorsky encountered a disaster that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a glitch caused his head to accidentally come into the direct path of a proton beam. The beam, with a force that defies comprehension, passed through his skull, entering through the back of his head and exiting through his nose. Bugorsky's experience was surreal. He saw a flash brighter than 1,000 suns but felt no pain. The beam's path left a trail of destruction, burning tissue and bone, yet he remained conscious and even walked to the center for treatment. The consequences were both horrific and fascinating. The beam caused localized tissue death, resulting in the loss of hearing in one ear and partial facial paralysis. Yet remarkably, Bugorsky's cognitive abilities remained intact, allowing him to continue his scientific career. This incident is not just a personal tragedy but a cautionary tale that highlights the immense power and potential danger of particle accelerators. The risks associated with a particle collider like the LHC are not to be taken lightly, as the potential for unforeseen reactions and the manipulation of the very fabric of reality are serious concerns voiced by some in the scientific community. Local area: the universes. Insider facts are simple toys as well as instruments of gigantic power. One of the most disturbing and charming concerns related with the LHC's tests is the chance of making a smaller than expected dark opening. Dark openings are districts of spacetime where gravity is solid to the point that not even light can get away from the astronomical vacuum cleaners. The devourers of stars, the mysterious elements that hide in the shadows of our universe that the LHC would be able make such an element even on a minuscule scope is stunning for the overall population, and specialists the same could this dark opening develop, wildly gulping the Earth from inside. And however, researchers at CERN have guaranteed that any dark opening made would be unsteady and dissipate nearly in a split second. The remote chance has lighted discussion spheres and a feeling of wonderment at the power we employ. It's essential to comprehend how the LHC could make a dark opening. It has to do with the essential mechanics of molecule gas petals when protons are crushed together at almost the speed of light. The energy delivered is huge to such an extent that it twists the texture of spacetime itself. Envision a trampoline extended rigid and then a significant burden dropped onto it. The texture twists, bends, and assuming the weight is weighty enough, it could make a misery so profound that anything close by would be brought into it. That is a short-sighted illustration for what could occur in the LHC. In the realm of quantum material science, where the standards of the universe are both odd and delightful, there exists a hypothesis that extra aspects might be concealed inside our reality. On the off chance that these aspects exist, the LHC's crashes could take advantage of them, making a gravitational pipe that structures an infinitesimal dark opening. This mysterious dance of particles has even grabbed the eye of some world well-known researchers, especially the late Stephen Selling in his book Stare as He cautioned of a situation where the Hig's bond could become shaky at exceptionally high energy levels. This unsteadiness could lead to a devastating vacuum rod, a grandiose occasion that wouldn't just annihilate the Earth yet the whole universe itself. The regarded English cosmologist and astrophysicist Sir Martin Rees too communicated his own interests about the tests led at CERN in his book on what's to come, possibilities for mankind. He investigated the expected dangers related with atom smasher tests, including those at CERN. His words were not only preventative, they were touched with a feeling of existential fear. He discussed a most dire outcome imaginable, where a doomed examination could make a condition called vacuum flimsiness. This shakiness could in hypothesis trigger a stage change that would echo through the actual texture of space-time, the outcome an inestimable calamity that could bathe the whole universe. Rees's interests were not restricted to hypothetical thoughts. He relegated a likelihood to these horrendous results, but a low one. Yet, even a minute opportunity, he contended, ought to provide us opportunity to stop and think. The stakes are inconceivably high, and the edge for blunder is razor slender. The researchers at CERN have calculated the probabilities, run the recreations, and inspected the hypotheses to contend for the well-being of the LHC. Truth be told, Brian Cox himself recognized the significance of that's what mindful investigation perceiving. There are far and wide feelings of dread and concerns encompassing the exercises of the LHC. However, he underlined that there are thorough well-being estimates set up, broad surveys and conventions that guarantee the LHC's activities are led with absolute attention to detail. Cox consoled that the energies included are well inside what the Earth normally experiences, and the possibilities making a stable dark opening are cosmically low, regardless of whether one were made. Researchers say it would be so little, thus unsound, that it would dissipate instantly of energy, a peculiarity anticipated by Stephen Selling. Known as Selling radiation, it would be a passing snapshot of vast marvel, a brief look into the pit and afterward gone. Some have gone further, theorizing that the LHC's tests could open a entryway to another universe or notice. This idea, however, to a great extent excused by mainstream researchers, has caught the creative mind of numerous and has turned into a subject of interest, dread, and even legends. What lies past our world? Might we at any point incidentally release powers or substances that we don't comprehend? The thought of opening an entrance to damnation has indeed even been sensationalized in different media, fanning the fire of vulnerability. Yet how did this thought come to be, and what's the significance here? In the setting of logical investigation, the idea of equal aspects isn't new in physical science. String hypothesis, a main contender for a bound-together hypothesis of everything, sets that there might be more than the natural three elements of space and one of time. These extra aspects could be compactified or stowed away from our discernment, yet they could hypothetically be gotten to or uncovered under outrageous circumstances. Now envision the LHC as an infinite key, opening entryways that have been SEF since the earliest days of recorded history, when protons crash at energies up until recently never accomplished on the planet. They could in principle make swells or tears in the texture of spacetime. These tears could open pathways to aspects past our own, like breaks in a grandiose wall that isolates us from the unexplored world. The outcomes would be comparative, as though you were to drop a stone into a entirely peaceful lake. The effect makes swells, waves that spread out, connecting with all that they contact. With regards to the LAC, those Waves could be aggravations in the aspects themselves, waves that spread out into domains we can't see or fathom. Researchers at CERN are fast to call attention to that the energies required to make such an entry are reasonable, far past what the LHC can accomplish. The thought of opening a door to another aspect remains solidly in the domain of sci-fi. However, the very truth that we can ponder such potential outcomes, that we can investigate the limits of our comprehension and companion into the pit of the obscure, is a demonstration of the force of human interest and resourcefulness. For the researchers at CERN, it should act as a quiet advance notice that a few entryways once opened may uncover insights we are not ready to confront. The LHC. These examinations have not just raised logical and philosophical inquiries, however, lawful and moral ones too. The very demonstration of reproducing the states of the universe's introduction to the world, of venturing into the early stage soup of presence and mixing it with our innovative spoons, has touched off, discusses that rise above the limits of science. Are we playing God? Are we stepping on consecrated ground, intruding with powers that were when the sole area of the universe? These are not simply explanatory questions, however profoundly disrupting requests that challenge our very comprehension of morals and obligation. The production of a scaled-down dark opening, for example, isn't simply a logical interest, however a potential Pandora's crate. Envision a whirlpool sucking all that into its inescapable grasp. However, on an infinite scale, a few lawful researchers and ethicists have addressed whether humankind has the right to face such challenges, even in the quest for information. Claims have been recorded looking to end the LHC's tests, referring to worries about security and the potential for horrendous results. The discussions rage on, not simply in courts, but in the halls of academia, in the media, and around dinner tables. In 2008, a claim was documented in Hawaii by Wal L. Wagner and L. Sancho, who tried to stop the LHC's activities. They contended that the collider could create planet-gobbling black holes or never-before-seen peculiarities that could obliterate not just the Earth, but the whole universe. The claim requested a temporary restraining order against CERN, arguing that the organization had neglected to provide an environmental impact statement as required by U.S. regulation. However, the case was dismissed. It ignited a firestorm of debate and brought the LHC's true potential risks into sharp focus. Across the Atlantic, in Germany, a professor named Otto Rossler filed a complaint with the European Court of Human Rights, claiming that the LHC violated the right to life guaranteed by the European Convention on Human Rights. Rossler's concerns were rooted in the fear that the LHC could create infinitesimal black holes that could grow uncontrollably. Although both claims were ultimately fruitless, they formed part of a broader movement of concern and skepticism surrounding the LHC. They reflected a well-established tension about the unknown, a fear that our quest for knowledge could lead us down a path from which there is no return. CERN was formed in the shadowed aftermath of World War II, when the world was still licking its wounds and the reverberations of annihilation were an eerie reminder of human imprudence. It was at a time when the very fabric of society was torn, and from that turmoil, a gathering of visionary scientists tried to dream. They longed for a place where the limits of countries would break down, where the pursuit of knowledge would be a beacon of hope. They imagined a research facility, a pot where the secrets of the universe could be investigated, where the mysteries of existence could be unveiled. In this way, CERN was born as an offspring of war and intelligence, a symbol of what humanity could achieve when driven by curiosity instead of conflict. Throughout the years, CERN has been at the forefront of particle physics, contributing to our understanding of the fundamental forces and particles that make up the universe. The organization has been involved in various momentous discoveries, such as the discovery of neutrinos and the B and Z bosons, particles responsible for the weak nuclear force. The Higgs boson, a particle that gives other particles mass, was a hypothetical phantom, a murmured legend in the annals of physics. Its existence was a riddle that provoked researchers, a question enshrouded in the very essence of reality. CERN's determined quest for this ghost culminated in a moment that shook the scientific world. In 2012, the Large Hadron Collider finally uncovered the God particle. It was a victory of human creativity, a demonstration of our insatiable hunger for knowledge. However, the Higgs boson isn't the only mystery being explored by CERN researchers. In an astounding advancement, CERN's LHC has revealed a particle that defies our ordinary understanding of physics, the pentac. This particle, as its name suggests, is made up of 5 quarks, including an antiquark. This is a distinct departure from the more familiar protons and neutrons, which are made up of 3 quarks each. The presence of such a particle was not anticipated in nature, making its discovery a testament to the capricious and often baffling nature of the quantum world. The discovery of the pentac at the Large Hadron Collider in Switzerland has opened up a new frontier in our understanding of the universe. These particles may exist for just a trillionth of a billionth of a second, however, their implications could be timeless. They could hold the key to understanding how our universe is structured, how the fundamental particles of matter stick together, and how the strong force, the glue that holds the interiors of atoms together, works. The pentac quark isn't alone in its exoticism. Alongside it, researchers have found new tetraquark particles composed of 4 quarks. These discoveries are not merely adding to the particle zoo, they are reshaping our understanding of it. They are allowing scientists to begin categorizing these particles much like the elements in the periodic table, paving the way for a new theory and set of rules governing this exotic matter. Additionally, in May 2023, CERN's analysts made another significant discovery, the observation of a Higgs boson decaying into 2 muons. These findings mark a critical stage in confirming the properties of the Higgs boson. It is like finding a missing piece in a vast jigsaw puzzle, one that helps us understand why things have mass. Yet the mysteries of the universe are far from settled. Just in April, CERN reported the discovery of a new particle smaller than quarks and leptons. This finding challenges our current understanding of particle physics and opens up a new frontier in the quest to understand the fundamental building blocks of the universe.